Now it's being recorded. Okay. So okay. So in this session, I'll be covering primarily first thing I'll be covering is what is analytics. Okay, the kind of work that happens in analytics. So this is again this I have covered it for you guys, I guess, in a brief. But Vivek wasn't there in this session, so just a brief recap of what analytics is all about. I'll keep it very brief. Uh, then I'll talk about data and data types. Okay, the different type of data that we deal in analytics and different types of data. I'll briefly talk about some mathematics used in analytics. Okay, probably would have you guys have learned it in school and colleges, but just for the okay, because calculus or something that most of us forget after learning it. So followed by statistics, some basic statistics required, and probability. Okay, so that is going to be the next thing. Okay, then I'll be covering what is known as correlation analysis, and then regression. Let us learn as much as possible. If not everything can be covered, we will cover the next session, but let's try to finish all these things. Okay, 5 6 things. Okay. Okay, let me have a couple of more pages.
All 10 currency hydrogen.
Okay, all 10.
All 10.
All 10. Okay, okay, great. Thank you. Okay. So the first thing that we will see is what analytics is all about, and what the kind of work that is done in analytics. Okay. So I will not keep it theoretical again. Just to repeat you, I'll ensure that whatever I work with in my organization, I'll talk about that, and I'll also talk about my experience with analytics. Of course, there are many different type of analytics that even I am not aware of. All I have done, I've seen is I've read blogs and I've watched videos in different places, but there are this is very vast field, so you need to explore more and more on the internet. But I'll keep it very basics, okay, at a very basic level. So analytics is primarily about analyzing data. Okay, the word analytics has come from analysis. Okay, um, so analytics is nothing but analysis of data. So why do we analyze data? To get insight. Okay, to get insight. And what will we do after getting insight? Well, we can take better decision, right? So if you know more about your customer, if you know more about the organization, you can take more better decision, right? So for example, you want to buy a house, right? So probably you will be confused that whether the price, the cost is reasonable or not, or if it's legally is okay to buy, or will I be in trouble if I buy, right? So the more information that you get, the more data that you collect about this house, you'll be in a better position to take a decision that whether you should buy that house or not, right? So more information, more data, more analysis makes things easier for you to take decision, right? That's primarily why we do analytics. Okay. Now there are so many jargons used. Okay, nowadays people calling it as data science also. Okay, so analytics is nowadays used less. What is used most of the times is data science. Okay, so and if you ask me what is the basic difference between analytics and data science, actually there is nothing. There's just two jargons. But yeah, there are couple of things that ensure that is done differently in these two fields. Okay. First thing is that data science is a field that has come from primarily computer science. It's a computer science terminology, whereas analytics is primarily from statistics, and they are interdependent because statistics depend on computer science heavily, because programming, without statistical programming you cannot do any statistical analysis. Computer science heavily depend on statistics. Computer science, the analytics part of computer science, because computer science as such that it doesn't have an no statistical techniques, right? So the subject that is heavily used here is machine learning, or also known as statistical learning. Okay, so don't be confused. The reason I'm saying all these things is that don't be confused when people keep interchanging the names. Okay, when they're calling analytics sometimes data science. Well, the word data science wasn't there actually. It was coined by an Indian, DJ Patil. DJ Patil. He was chief scientist at LinkedIn. Okay, and he wrote an article for New York Times or something like that, where he, instead of using analytics, he used data science, and that's, and after that it became a very buzzword, and people started using it, and people started liking it. And in IT we always want a new term, okay, because that's the way you will market yourself, right? If you do not have a new product, at least you should have the same product with a different name, so that you can um, so that's how it came. But another thing why data science is something totally new field is because the kind of data. So analytics has been in operation, or has been in the world for very long time. When there was World War, also there was analytics. Okay, but we never used to analyze data of this volume. Okay, there used to be like 500, 10,000 or maximum 2 lakh population, but now we have like gigabyte of populations, terabyte of data, and because the electronic data. Okay, if you have like non-electronic data form, there won't be much data, but with electronic data, you have like just too much of data. Every click that you do on the internet is actually recorded by somebody. Imagine how many times you open your Facebook, what you do, every single thing is stored by Facebook or some other company. Okay, so a good amount of analysis can be done on this, and you can actually get to know that how the people behavior by doing analysis. And why data science is different than analytics to some extent is because in data science we actually deal with most of the times the internet data, which is of large volume. Okay, and we generally use machine learning techniques than the statistics techniques, because machine learning is pretty useful when the data size is quite large. So slight difference, but yeah, there is a huge overlap. Clear, right? Now, what kind of problems that one can actually come across? Okay. For example, if you're working in a bank, you would like to know that what is the probability that a customer is going to default on payment. So customer has taken loan from you, and what's the probability that is going to default on the payment? Okay, you need to know before the customer defaults, right? So that you will take necessary measures, right? If you know something happening beforehand, then you can take better decisions. You can take necessary measures to avoid such a risk, right? You can also know that if you want to roll out offers, okay, for example, if you're a car manufacturing company and you want to provide offers to some of your customers or loyal customers, how do you know that who are your loyal customers? Okay, so you probably get to know that if you give offer, who are the ones who are going to take the offer. Okay, probability of accepting offer. Okay, and then so many things are there. For example, uh, in your like a lot of times you might have you must be getting promotional mails, right? So on what basis they provide promotional mails? That's based on your your uh, transaction, yeah, whatever you do on the internet. Okay, somebody is observing you, and based on your behavior they analyze that you're of what type of person, what kind of products you're going to use. Okay, so based on that, they provide you offers. Okay, they contact you through your email ID. Um, because otherwise, if you are not likely, for example, you never watched movie, and people provide you, coupons for a movie ticket or anything. It's of no use, right? So they need to know that okay, they need to categorize people into different categories. Right? That okay, these are the people who like movies, these are the people who like sports, and then who are foodie, they want to travel. So somebody who doesn't travel and you're providing some offers, it's of no use, right? You simply waste your time on money. So that's important. Then there are many things actually you can do. For example, you keep getting emails, right? And emails are divided, categorized as good mails and then spam, right? So there is an algorithm which observes your behavior. That which mails you are actually categorizing as spam mails. Okay, so based on your inputs, the algorithm does the classification of mails automatically. It doesn't have to depend on yourself. It does it automatically. Right? It happens. We never did it, but it could go wrong sometimes. Okay. Is that because of the sound? Hello. Can you hear? Huh? Okay. Okay. Great. So I was talking about how emails are classified to spam mails and good mails, right? So what decides that an email is going to go to the inbox or an email is going to go to the spam box, right? So that is also done by an algorithm or a machine learning or a statistical algorithms. So using that algorithm, the mails are classified into good and bad mails. Okay. So how does it know? It studies the behavior of the individual, how it classifies mails into different categories, and based on that, the algorithm does. When you do a Google search, right? That you also get a lot of product links from the Google. It suggests, right? So how does it happen? Even that happens through different analytical techniques, okay, known as web analytics. Okay. So these are primarily areas where analytics is used. It's almost used in every areas now. Whether it's telecom company wants to know like chances that a customer is going to go to a competitor. Okay, the telecom company would like to know. The bank would like to know where the customer is going to default. How many customers are loyal customers? Okay, if I provide more services to the customer, is it going to be profitable for the company? What are the potential risks from different sides of the business? Okay, what are market risk? What is the operational side of this? Right? The bank would like to know. An e-commerce company would like to know that what and on what date, if I give an offer, the sales is going to be maximum. Okay, so is it going to be a couple of days before Holi or is it on the very day of Holi? Right? So these are the questions that one would be asking in an analytics, or even in any business. Okay? Nowadays, there are almost individuals, oil and gas, whether it's banking, whether it's manufacturing, telecom, retail, e-commerce, anywhere, everywhere, even in government, even in like any other organization you see nowadays, analytics is being used heavily for decision making. Okay, so this is very much about analytics. You can go through a lot of materials on the internet. You can watch, you can read blogs here. One blog is known as Analytics Vidya, and there is Analytics India magazine. Just to familiarize yourself with the different jargons and different what's happening in the industry. You can also watch my channel here, Analytics University. I'm soon going to have a blog, so you can read that blog. So these are certain initiative in India. Okay. There is another company also, big data. Okay. And at an international level, if you want to know, read KD Nuggets, then Data Science Central,
What is this? Red.
Nuggets, NU,
Acha, nuggets.
yeah,
Red nuggets.
KT,
KD nuggets.
yeah, Data Science Central. Okay, so these are the popular blogs, YouTube channel on the internet. You can go through all of this. Okay, so what are we going to use? We are going to use both SAS and R. Okay, SAS and R are the most popular softwares. Okay, programming languages. In fact, you can do analytics on many other things. You can use Java, C++. Okay, yeah. Java has its own library, C++ has its own library. Python is now becoming very popular. So if you learn Python also, you have heard about Python. Do you know Python? If you can learn Python also, that will be also great because Python is now becoming very popular in analytics.
Very analytics.
Yeah, analytics. SAS obviously is a market leader, but it's losing its market.
So, like Python is used with R.
No, Python is used. Python has its own package, statistical package. It's primarily programming, so it's not like tool the way you use SAS. SAS also has many tools and it's got programming.
So you have to do pure programming.
Yes, in Python you have to do it. Even I have never worked on Python, so I cannot give you a good idea about what Python is all about. But you can get a lot of. So it doesn't matter actually. I'm not a great fan of languages. All I know that if you know the techniques, you can learn any tool language. It doesn't matter. But my focus will be on SAS and R. Okay.
Python is open source.
Open source. R is open source. Python is open source. SAS is proprietary. Okay.
So like SAS and R can be used collectively or like
Yeah, you can import SAS code to R code to SAS nowadays. Nowadays it's possible. There is also another software like SPSS from IBM, right? Okay, which I hate it. So, so that also you can use.
So is it good like SPSS?
SPSS I have used, but I didn't like it. So if you guys like it, I don't mind. I can use it.
So like, have you ever worked on this?
Yes, I have worked on SPSS.
So I mean, just to like, because like I'm currently working in IBM, so in case like we could give a POC or something.
Mm-hmm. So yeah, SPSS is something that it is definitely possible. It's very easy. So,
And nowadays Watson analytics is also.
Watson, IBM Watson, right? IBM Watson. These are all tools, right? Okay, based on R and SAS packages they are doing all these things. So you need to learn analytics, I mean statistics part. Later on you can just specialize in one tool and
Switching tools is
it's not a big deal. Okay. IBM Watson is there. Microsoft का अपना है. Microsoft, right? Amazon का अपना है. Amazon का अपना है. So Revolution Analytics का अपना है. Okay. And then you have tools from Hadoop, Cloudera, Hadoop, Hortonworks. Okay. So don't be worried about tools at this moment. You learn the basics first. Later on, you can build up. Okay. It's like it's going to be lifelong. It's very vast area. Okay. It's going to be lifelong and intellectual learning experience. Okay. Keep on learning new tools because every 6 months we see a new tool. It's a new area, right? That's why.
So like right now, SAT is the leader.
He is asking that whether R is tough. Actually, not. It's easy. It's pretty easy actually. It's pretty easy to learn. R is pretty easy to learn. I can show you how to use R. Okay. In fact, my R window is open. Both R SAS window is open. Okay. This is how R window look like. Okay. Very easy. For example, you assign something in okay in R console. So A is equal to 2. You can't see, I guess. Can you see? Okay, so A is now assigned as 2. Press A and give 2. I mean, it's very simple actually. So Vivek, can you see my screen? The R window? Okay, great. Okay, so this is how R look like, and my SAS is also open. I will show you. Okay, don't worry. So let us learn first what is data and the different type of data that we are getting. Okay. Well, data can come from any source, internal source, okay, like your transactions, business transaction, right? And it could come from external source. For example, say for example, your company has a product. So how this product is being received by the population? From where will you get data? You will get data from Twitter, what people are talking about it. You'll get data from YouTube comments, right? You'll also get data from Facebooks, right? You can analyze all the hashtags and get to know how product is doing, right? So that's external data. Internal data is transaction data.
What is the importance of hashtag?
Hashtag, even for a long time I was not aware of it. Hashtag is about when you hashtag anything, any of your whether any comments or anything that you are doing on, so it gets recorded in a certain category. Okay, so what happens is that it's stored in a classified form, so you can actually extract and manage the answer.
Because nowadays Google has launched hashtag making specific.
Okay. Nowadays everybody is doing hashtag. I don't know. This was actually from Twitter initially. Facebook has now implemented it. Now even Google Plus everywhere.
So like a hashtag is a separate category altogether.
No. It's just for example, if you're doing, I'm posting something on analytics, and you has analytics. So this will be categorized that analytics, the bunch of posts on analytics. My post will be categorized in that category. So if somebody searches in Facebook, okay, about all the discussions happening in analytics, my post will be there. Yeah. So it's better. It's easier to classify and it's reachable. Right. The moment you put hash, it becomes a link. Okay. Otherwise, it's just text, simple text, which is very difficult to categorize. Yeah. So that's about it. And data could be of any type. Okay, it could be an image, it could be sound, it could be text data, it could be numerical data, numbers. Okay. But most of the times we get numerical data and text data. Sound, image is something that is beyond my reach. I've never gone this data, image, sound, and all. But yeah, people from pure computer science they actually work on image processing and all that, computer vision.
So mostly banking must be using.
Yeah, text right, text and numerical data. Okay. So data is actually primarily divided into two types. Okay, although there are many other types of data. Okay. One is your numerical data. The other one is text data, a categorical data. Sorry, we'll go to the next slide. For example, age. I'll take age of customer. Okay, 22, 25, 28. So this is first of all numeric, right? number data, known as numeric data. Is this continuous or discrete? So what is the difference between continuous data and discrete data? This is continuous because we can have age between any, right? We can have a age of say 22.5, we can have 35, 90, any, right? It's range bound though, it cannot be 150, but yeah, age can be anything, right? That's continuous data. That could be discrete data also. For example, we have gender, right? Gender could be one or two, male, female. So that's become discrete. Or for example, customer type. Um, many other things can be done. Discrete data और क्या होगा? Yeah, number of children. Yeah, number of children. That's possible also. Number of children. So those things are actually discrete data, where you cannot have a data between two data points. For example, if different types are like one type, second type, third type, you cannot have something like 1.5. So it's a discrete data. It's a discrete data. You cannot have. So that's about it. And then there is one type of data called categorical data. Okay, different categories. For example, gender. It's a category 1, category 2. Right? That's categorical data. Okay. And why we segregate this data types is because the kind of analytics that you can do on numerical data, you cannot do that with categorical data. Okay, so there is a little bit of difference between them. So once you collect data, the first thing you need to do is that data validation. Okay, what is data validation? Well, data validation is about validating whether the data that you have received is actually correct or not. If it's not correct, then there is no point to analysis on that. There is a check. There is something. What is that? Garbage. Sorry, what is that? Garbage in, garbage out. Garbage in, garbage out. Have you heard about this? So if your input is garbage, your output will also be garbage, right? So data is always treated as input, right? So if the data itself is wrong, okay, you have used wrong data, your output or insight will also going to be wrong, right? If you are using customer information, ensure that it's right. How do you ensure that it's right? You need to do a lot of validation things. For example, you come across a case where the salary of a customer is suspicious. For example, it's like 4 crores annually, 4 crores. Like somebody's salary may not be 4 crores. You need to go back and see whether that person's salary is 4 crores or not. Or is a typo or there is some issues. Okay? Somebody's age is 150. It cannot happen. Right? So you need to go back and see all these things. So data checking is one of the most important things. When you receive data, ensure that it's good enough to use and it's proper. So do this little bit of checking. Common sense. It's very common sense. Okay? You do not need to use any statistical techniques for that. Pretty common sense. Just ask whatever number of questions possible and just check whether these questions are answered. Okay. Is that right? Is that wrong? So just ask as many common sense questions. Okay, so that's about data and different type of data types. We'll see data types. We'll talk more about it when we actually do case studies. Okay. I'll talk about now a couple of mathematical techniques used in analytics. Okay. So all of you are familiar with what is a linear equation? What about Vivek? Yes. Just a brief recap. Okay. So linear equation is like, okay, y is equal to 2 plus 5x. That's a linear equation, right? Why it's linear? Because the degree is 1, right? But this is not a linear equation, right? Yeah. So y is equal to mx plus. So what is m here? What do we call it? Slope, right? And what is say? Intercept, right? So when we plot it, a line, y is equal to mx plus c. You take this is slope, take the tan theta, you call it as a, right? The slope, and this area is the intercept, correct? Oh, now you do not remember all this? Okay, no problem. Just brief recap, okay? You do not have to know all this thing again. I'm just brief recap, okay? So this area is known as, this part is known as intercept. The slope is known as, it's the tan theta of this thing, okay? So slope, okay? So if you know aim and c, you can actually write equation of a line. So all you need to know is that aim and c, okay? Intercept and in technically we call it, these are parameters, or in statistics we also call it as estimates. So if you get to know aim and c, you will be able to find out the relationship between y and x. Okay, so the whole purpose of doing all analysis in analytics is to find out what is aim and c. Okay, so we will see all this. So what are the mathematical techniques that you used? Okay, first you must be comfortable what is exponential and logarithms. Okay, so if say for example y is equal to 2 to the power 3, so what is log of y? 3 log 2, right? You take the logarithm of this, the power will come to the, right? So 3 log 2, what is log 2? 1.42, right? 3 into 1.42. This will be like 4.2. Okay. Similarly, exponential. You need to know what is exponential term. Okay. For example, if x is equal to say 2, what is e to the power x? So e is e to the power x nothing but 2.7 to the power 2. Okay. So exponential is something but the opposite of logarithm, right? If y is equal to log of x, implies that x is equal to exponential of y. Okay. This is the basic mathematics, we all have learned it in school, in junior college. Just a recap of all these things. Okay. The next thing that we need to learn about in mathematics is the derivative, integration.
We should look at these things also.
If you look at this will be, your life will be easier in next, because I have a lot more mathematics later on. Okay. So derivative. Okay. So derivative is again, derivative is used for what? Why we use derivative? Derivative used to see the nature of the function, right? So before that I should tell you what is a function, right? Y is equal to f of x. So f is a function which relates y and x. So it's just a rule that relates y and x, right? So x is equal to, say, y is equal to a plus b into x squared, right? The relationship between y and x is given by this equation, right? So when we do derivative, we try to find out the relationship between y and x in a very granular form. Okay, so when we say dy by dx, what do you get? A plus b into x when you take the first derivative. I'll talk about derivative, don't worry. That means change in y with respect to change in x is given by this equation. Okay, so and why do we need it? Because if you know what is the change in x, you will also get to know the change in y later by using these equations. Okay, easily. Say for example, so what is the rule of derivative, right? So if y is equal to x to the power n, dy by dx is equal to n x to the power n minus 1. Is this clear? Is formula clear? Now this is just a formula. Okay. So if y is equal to say x cube, so what is dy by dx? He remembers. Vivek remembers. Okay. Okay. So dy by, what is dy by dx in this case? if y is equal to x cube. Just use this formula.
3x
3x or
3x square.
3x square, right? Right? So if it is x to the power 5, then
4x cube.
5x to the power 4. Right? The derivative of log x is 1 by x. Okay? The derivative of exponential of x is the same exponential of x. Okay. So these are the simple mathematics that one need to know before learning analytics, because later on we'll be dealing with a little more complicated mathematics. So it's always good to have this in background so that don't have it. No. You will not have to remember all this formula, because I think algorithm will take care of all this. So don't have to.
Just as a concept.
Yeah, no.
Conceptual.
So you're saying that people in computer science background, people don't know mathematics? Achha. So how do you get control A? Alt
N.
A, right?
Just press Alt N.
Okay. You know what is
Alt N.
Control and
Sorry, control N.
control and अभी
control and shift and try out
तो previous case में जहाँ से हमने ऐड किया था
नहीं
जहाँ से हमने वो राइट क्लिक करके ऐड किया था ना वही भेज दिया
माइक ये वाला यूज हो रहा है
अरे
ये वाला माइक यूज हो रहा है
यहाँ से ऑनलाइन
अभी यहीं पे
अच्छा ऑनलाइन कंट्रोल लेन
नया presentation. Anyway, we'll experiment later on.
tensed इसको लग रहा है उसका स्किप
इसको बोल दो भी
त्रिपाठी साहब मिठाई खाओगे क्या
no. He is not getting that.
कुछ नहीं वो स्लाइड्स ऐड कर रहे हैं 2 मिनट
अच्छा वो देख रहे हैं वेबकैम पे देख रहे हैं
क्या
कुछ लैंग्वेज बोल मर गया ना हिंदी में
ठीक है okay so where were we discussing about mathematics, right? Okay, anyway we will not use this all this in like I'll keep it I'll ensure that we do not use too much of mathematics.
one more thing with respect to mathematics if you could like brief us what all things we need to learn, because in interviews they might ask these things. Right?
Nobody is going to ask you to do a differentiation of this. But yeah, if you can brush up things, you want to get to that. There are so many mathematics techniques. You just learn what is derivative, basic derivative, basic integration, basic limit, logarithm, exponential, linear regression,
Which is
and
easy.
functions. Okay. So now we have got like the basics of mathematics that we just saw, right? We also need to learn basics of statistics. I'll provide you more material on this. Okay, I have study packs, so you can go to all these. And also give you materials, more materials on this. Okay, just take a look at it. So, what are the statistics things we need to know? First thing is that we need to what is known as descriptive statistics. Okay. So, for example, if you get in a college, you know that the students of a college get a salary of 2.5 lakhs to say 10 lakhs. So how do you decide that whether you should join that college or not? Will you take a look at the 10 lakhs salary and make a decision whether you should join that college? No, right? So you will be wanting to know what is the average package, right? So what is average? Average is nothing but statistical known as mean, right? So mean is one statistic that we look at before making a decisions, right? So we need to know what these basic statistics are in order to be able to analyze them better, right? So in the descriptive statistics, we need to know what is mean, what is median, what is standard deviation, variance, maximum, minimum. Maximum, minimum, you know, right? Maximum value, minimum value, right? You can do it in SQL also. You can write SQL here. Mean is also possible, right? In Excel sheet also you can find out what mean is. Right? Median. Any idea what median is about? Median is what? Huh? Yeah, the middle value, right? And mode, you know what is mode?
Mode is rounding off.
Mode is the number that appears maximum number of times. Okay. Yeah, the highest frequency, the one with the highest frequency, that's the mode. Okay. Any idea what is standard deviation? What is variance? No.
From median, the standard.
Means we consider standard deviation.
Standard deviation. For example, I'll take an example. Okay. Salary. We will do the salary. Okay. Say for example, the average package in a college is 6. Okay. And say there are 5-6 observations. Okay. 2, 4, 6, 8, 10. Okay. I hope the average is 6. Anyway, whatever. So we will first calculate what is deviation. So deviations means actual observations minus mean. 2 minus 6 minus 4. This is the deviation. 4 minus 6 minus 2. 6 minus 6 0. 8 minus 6 plus 2. Similarly 10 minus 6 plus 4. Right? So these are all deviations known as deviations. If you add all these deviation, what will you get? You'll get 0, right? But we get what is known as standard deviation like this. Okay? We'll just square all these things. So minus 4 square, minus 2 square, 0 square, plus 2 square, plus 4 square. Okay? So this is sum of your all your deviations. Okay? And you divide it by total number of observations. How many observations are here? 5, right? Okay? And you take a square root of that. We call it as standard deviation. Clear? What is standard deviation? If you remove the square root, we get what is known as variance. Okay? So variance is actually square of the standard deviation. Clear? Right? So, and question is now that why are you using it? What's the purpose of having the standard deviation and variance? Okay, let me tell you one thing.
Standard deviation is this and variance is
Just
acha.
remove the square root. Okay. So why are we doing it? Okay. Standard deviation actually or variance both actually talk about the same thing. There are two different measures, but the significance is okay. So the significance of these two measures are it actually finds out the spread of the data. Okay, how well spread it is. Okay. For example, you may have a data which is like this one. Okay, and you have a data which is like okay. So which one is more spread? Right, this one. So the standard deviation will be more in this case. Okay, it will be less in this case. If you can take an example, say 1, 2, 3. The average is 2, mean is 2, right? Say for example, let's take this much 1, 2, 3, 4, 5. Okay, then let's take another thing 2, 3, 5. Okay, no, okay, 1, 2, 3, 4, 5, 2, 3, 5. So what's the mean in both the cases?
3.
Both the cases, right? The mean is 3, right? Did you get the point?
Yeah.
So in one college you will see the package to be this, the other college the package to be this one. So which college you would like to join? Use your common sense.
Second one.
Why?
This will come in package. One like me.
But the average package is same, right? The average package is 3. You know, we saw that we care about the average salary, and average salary is same. So now question is, are these two colleges same or there is a difference? So even they is same. Okay. Think about it.
Standard deviation.
And why standard deviation matter?
Because of distribution of data, like we would understand how many people have.
See, will you like to go to a college where the difference between the maximum and the minimum salary is less, or the difference between the maximum and minimum salary is more? Less, right? Why? Because you always think that you are the biggest loser in the world, and you might fall in the bottom, right? You always care more. This is a human psychology, right? So we always also look at what is the minimum salary, right? Even if you cannot get the maximum, at least what's the minimum? Okay. So that's important. What's the minimum salary in the first case? 1. The minimum salary in the second case is 2. So the second is better in this case. So what is more important is not just minimum maximum. It is also important to know the standard deviation. Okay. The more the standard deviation is, the more variation in the data. Okay. So that could be helpful. That could be not so helpful sometimes. Okay. If there is so many variation of data, you will never know where you will get to, right? What value will you get, right? So there will be more uncertainty, right? So you will prefer where there is less variation. Okay. That's right. So that's the way we analyze data. Again, the final decision always depends on many other things. It's not the the standard deviation that matters. People look at other things also. Okay. So what else you would like to know? Well, we learned about mean, median, and standard deviation, variance. Right. Okay. The next thing is that we are going to learn what is probability. Okay. Any idea what is probability? Have you? Most of you know.
Chance.
Probability about chances, right? If you toss a coin, so what is the probability that you will get head? Vivek, are you with us? Can you hear us? Yes. Should also answer sometimes actually. Since yeah, great.
So it's 1 P1
Yeah. So how you calculate probability is that the favorable cases by the total number of cases. So when you toss a coin, how many? What are the total number of cases? Two, right? Either you will get head or either you will get tail. And what is the favorable cases? What do we want? We want to know what is the number of heads. That is just once, right? So the probability is 1 by 2. Got it? If you throw a dice, it has got 6 faces. 1, 2, 3, 4, 5. So what is the probability that you will get 2? 1 by 6. Got it, right? So probability. So what is the probability that you will get an even number?
2 by 5.
Right? 3 by 6. Got it? There are 3 even numbers, right? If you toss a coin and throw a dice, let me make it a little more complex. You toss a coin and throw a dice. What is the probability that you get head and you get an even number? You get head and you get even number.
Multiplied.
Hmm?
Multiplied.
Tell me. What's the answer?
3 by 6. So it would be 3 by
3 by 12. So what is 3 by 12? No, that's fine. That's the right answer. So it should be 1 by 4. How? Yeah, that's a good question. Okay. So the probability that you will get head is 1 by 2. The probability that you will get an even number is 1 by 2. Right? What's the probability that you will get both when you do the experiment 7 times? You just multiply. Okay. And so whenever I use and here, you just multiply. If I have used or here, what is the probability of getting head or even number?
Then we add it.
Okay, add it and subtract the common part. Okay, probability of A plus probability of B minus probability of A intersection B. Okay, just forget about it. Okay, it's more complicated. Okay, he's writing something. What will be for our situation? Okay, we will see. Okay, we will see. So let me make it like this. Okay. So what will be the cases? T1, T2, T3, T4, T5, T6, T7. Sorry, that will be not 7, right? Got it? Then we'll have H1, H2, H3, H4, H5, H6. What is to answer your first question, right? What is the favorable number of cases? You are getting head and an even number. How many times you are getting that?
3 times.
Total number of cases?
6.
6. How can it? Both right? Huh?
12.
You are doing dice experiment, and so how many total number of pairs you will get? 12, right? You got 12 pairs, right? Total number of possible cases. 12. So that's 4. What about when it is? No. I'll come to the OR case. I'll come to the OR case. Okay. Now, when there is OR, okay, if I say that what is the probability that you get head or even number? What is the English meaning of OR? When you say you get this or that means either is fine. If at least one of them is okay, it's fine, right? So how many of this? Just look at the pairs. How many times you are getting head?
6 times.
6 times. How many times you are getting even?
3 times.
3 times. Out of that is 3 times. But you will also getting evens there, right? Look at the top.
Okay.
6 times.
System.
Right? But there are 3 commons here. Then you get both head as well as even, right? So we cannot double compute, right? So now how many times you get head or and even, right? All 6 are head and then another 3 evens here. Got it? So there are 9 favorable cases here and the total is 12. So this in this case it's going to be 3y. Is it clear or should I explain further?
Yes.
Clear?
6 from this
And
and
3 from
3 1 from
top, right? It's or. Just think about it. Or means out of these two numbers or two quantities, if one of them satisfy, that's okay. For example, T2, right? Now we do not have head here, but we have even number here. So at least one of that is there, right? So we will count it as favorable case. Similarly, H of 1, we do not have even here, but we have head. So that also is counted as a favorable case.
complexity. This is generalized formula.
Okay, so the generalized formula is that P of A union B is equal to P of A plus P of B minus P A intersection B. Okay, so in our case, if you look at so we had 1 by 2 in the first case, 1 by 2 in the second case, and what was the common thing? 1 by 4. Okay, if you will get it 3 by 4. Okay, so this is P of A, event A, P of B, this is P A intersection. Or in other words, this is probability of getting a head, this is probability of getting an even number. Okay, this is probability of getting head and even number. Right? Okay. Good. So a lot of mathematics to it, right? So this is probability. Now why is probability so important? In analytics, we always calculate probability, chances. What is the chances that the customer is going to buy your product? What are the chances that a certain number of customers are going to default on the loan? So always care about chances of happening of an event. Okay, so that's why we need to understand probability very clearly. Okay? So more than probability, what is more important is probability distributions. Okay, so now these things are very simple. The probability distribution is little more complex. Okay, where there is a function associated with probability. Okay, and before that I'll talk about what is random numbers. Okay, so we'll also learn what is random numbers and what is probability. So random numbers, I don't know whether you've heard about this term or this very first time. Have you heard about this term?
Yes.
Huh? What's the random number?
Generally random.
That is mechanical, but what is the theoretically what is a random number? See, random number is always associated with an experiment because you never know what is going to come for sure. For example, if you toss a coin, you never know what is going to be head or tail, right? For sure. So the value that you associate with the random number, with the random experiments, okay, whether it's tossing a coin or throwing a dice, these are all random experiments. Okay, so values associated random experiments. Okay, so for example, we get head and tail, but we always get with a chance. Okay, so head 0.5 probability, tail 0.5 probability. So we always associate the random numbers with a probability value. So this nature of the data is probabilistic in nature. So there will be data which are non-probability type. We also call this as stochastic in nature. Okay, there is non-stochastic data also. We also call it as Okay, thank you. Thanks for the info. Um, okay, so this is probability data. Sometimes you also get non-probability data, or we also call it as deterministic data. Okay, age of a customer. If I ask what is your age, you will never say that the probability that my age is 35-year-old and 35 is 0.5. The probability that it is I am 90-year-old is 0.2. All right, it's either it's a fixed date, right? It's a fixed age, right? There is no probability associated. So this is not a random experiment. Right? This is purely deterministic. So we call it as deterministic data. Okay. Most of the data that we get in analytics is always stochastic in nature. Analytics deals with the stochastic nature.
Stochastic means fixed.
Ulta
Ulta.
nature of the data. Okay. Analytics, because if there is no stochasticity, there is no point in analyzing, right?
So age is stochastic or non-stochastic?
Sorry?
Age is stochastic.
Non-stochastic, right?
Non-stochastic.
There is no probability associated with this, right? So, if it is non-stochastic in nature, it's deterministic in nature, there is no point doing an analysis, or its analysis will be easier. If it's stochastic in nature, okay, if you know that how many customers are going to buy your product, there is no point doing an analysis, but that could vary, right? That could vary with time, could vary with, right? Stock price, very non-stock, very stochastic data, right? We never know when it's going to go up, when it's going to go down. It depends on so many things, right? That's why we are so interested in stochastic behavior, stochastic nature of the data, and we always analyze the stochastic data. Okay, so that's about difference between stochastic data and non-stochastic data. Got it, right? But we were learning something else, right? I forgot. What were we learning? Go back. Okay, random numbers, right? Okay, so he wants me to explain stochastic data again. So stochastic is nothing but its probability. Okay, so as I said that if you do an experiment like tossing a coin or throwing a dice, it's a random experiment because you do not know what is going to be the outcome of your experiment, right? So here we actually associate a probability value to the outcome of experiments, right? So we call this a stochastic experiment. The data that we get is stochastic in nature because we are not sure. Okay, if you throw a dice three times, are you sure that what numbers are you get? You can get 1, 2, 3. You can get 3, 4, 5. You can get 1, 4, 6, right? So there is always a probability, right? So what is the probability that you will get 1, 2, 3? What is the probability that you will get 3, 4, 5? What is the probability that you will get 1, 4, 6? Right? So there is always a probability value that is associated with the data. Hence, this data is known as stochastic data. But if you ask me what is my age, I'll say my age is 27. Okay. There is no probability that my age is 27. There is no probability that my age is 29. Right? It's just that my age is 29. Okay. So that is deterministic. Okay. And in analytics, we only deal about stochastic data most of the times. Okay. Because that's more interesting, right? We try to find out the uncertainty in data. Because in stochastic data, we'll have uncertainty. Certainty, right? And that's more interesting. That's why we do all these analytics. Okay, what will be the consumer behavior? How many purchases will happen? What are the chances that a customer is going to be buying? There is always a probability associated with it. So this is like a random experiment, right? We do not know the consumer behavior, right? And the same person could behave differently. For example, you might be getting promotional mails from Mitra or Jabong or Flipkart, right? So you saw the email many times, but you actually make a purchase only once, right? Well, you have been seeing the same mail again and again, but you never made a purchase. But one day you did it. The same person, same email ID, but makes two different. So if you make a purchase on say Monday, so the company will get to know, okay, this guy is actually making purchases on Monday. So that's one extra information that you get. So there is always an uncertainty associated with this. That's why this is called stochastic analysis. Right? Right.
So, like generally, when we derive conclusions, how much importance do we give to this stochastic data?
Well, it's inherent actually. So you don't have to specifically mention that this is stochastic. That's why we do this. It is understood that the nature of the data is stochastic. So you don't have to take care of it, in a separate way. Okay, you don't have to give it a separate attention.
So when deriving conclusions, you take both stochastic and certainty.
Yeah, certain and uncertainty. Certainty is not of much issue. For example, most of the times you will not be dealing with certain data, a situation which is very much certain. Otherwise, what's the point in doing analysis? You know something is going to happen, right? But if you are not sure something is going to happen, then you are curious about it, right? You know what's the probability or what the chances. Okay, so that's about what's stochasticity. Then the next thing that is more important is probability distribution. Okay, so probability is actually a function of some variables. Okay, the probability of happening of an event is a function of different data points or different outcomes of an experiment. Okay, in this case, in the toss experiment, in the dice experiments, the probability is constant throughout, right? The probability of getting 1 is 1 by 6, probability of getting 2 is 1 by 6 in the dice experiment. Right? So we call it as a uniform distribution. Why uniform? Because probability is same, but it will not be same all the time. Okay, so there will be so many type of distributions. We have binomial distribution, Bernoulli distribution. I will not cover all these things. I have given you study packs. Just go through this. Normal distribution. Okay, so what is more important for us is that binomial, Bernoulli, and normal. These three things are very important for us. Okay, we need to understand these three things to be able to do analytics. Okay. So normal distribution, I'm sure you might have seen this kind of a graph, right? Have you ever seen this kind of a graph? This is also known as a bell-shaped graph, right? I will not cover everything in detail. Just go through all this thing because we should not spend time on trivial things. If you have an issue, just write to me or we'll cover it in next class. Okay? So here you get a mean in the center. Okay. Then this is spread across your plus infinity and minus infinity. Okay, this is 0. Okay. And we in the here we get probability. That means the probability is distributed like this. And x-axis, this is x value. Okay. And this is more important for us because what happens is why this distribution is so important for us. I'm talking about that. Okay. So, for example, you want to know on what salary depends. Right? Salary depends on what, right? You will see that the salary distribution is again normal. Say, some people will be getting less salary. Most of the people will be getting average this salary, right? And some people will be getting very high salary, right? Similarly, if you want to know different types of customer, some people will be like they're not purchasing very much. But a lot of people will be in that average category, right? But very few people will be in that extreme average category, extreme category, right? So you always get a curve like this in most of the business model, normal curve. That's why normal distribution is very important for us. And most of the modern predictive models, use this assumption that the data is normal distributed. Although in practical real life, it is not always distributed normally, but theoretically we think this. Okay. So what else to be learned? Okay. So I'll stop it here. I'll stop the basic theoretical question over here because we have learned so much of theory today. We'll do a little bit of practice application now. Okay. We'll go to SAS and we will learn the basics of SAS. Are you guys familiar with SAS?
I've seen the university edition.
You have installed and you have done your development. So I'll whatever Vivek, are you familiar with SAS?
Actually, correlation regression, that could be discussed. Correlation and regression.
So we will see that. Okay, so I'll familiarize you guys with SAS, and if possible today also we go ahead with correlation and deviation. I want to cover this actually because I want to give you a couple of assignments on that. So that's important that we learn. Are you guys available tomorrow also?
Yes.
Right. So whatever Vivek, are you available tomorrow? Yes. So we can also meet tomorrow, right? For say hours. Because we want to finish as soon as possible. That will be great for you. Right? Because I'll tell you one thing. I believe in one thing. I do not want to make it like a classroom teaching that you all have already done in college. Because that's a bit boring actually. If you keep on learning things, and because all that what I have taught you is not going to be used in industry when you work. So I want to teach you more what you are going to use in the industry because that will increase your confidence. Theory is like it's a lifelong learning. You have to learn it like all your life on your own. So your application is more important. Okay, so I just want to finish the theory as soon as possible so that we will do more case studies. The more number of, so I'm having case studies for different industries, retail, marketing, even this for finance and all that, for industry and different business domains. We'll do case studies so that will increase your confidence level. When you actually go and write codes and do everything, so with the results. Sounds good? Okay, I'll stop it here. Let's learn SAS. Okay, I'll take 5 minutes break. Fine, right? Yeah.
And one more thing.